Perceptual Quantizer, or PQ as it's commonly known, is one of the standards recommended by the ITU for HDR production. Dolby has designed a nonlinear transfer function that encodes extended dynamic range matching the human visual system. Dolby ran an extended range viewer study where in a cinema-like environment they displayed images with different contrast and brightness levels, from the normal TV experience that goes from 0 nits to 100 nits to images that ranged from 0 to 20,000 nits. 90% of the viewers concluded that the screen that could display images that ranged from 0 to 10,000 nits delivered the most pleasing and convincing images. Based on this theoretical 10,000 nit max screen, Dolby has developed an electrico-optical transfer function where every single brightness level has an absolute bit code value. Dolby defines diffuse white as that of the standard of SDR, 100 nits, and a bit code value of 519. Because of the logarithmic nature of human vision, 100 nits is roughly half as bright as 10,000 nits. That's why we can see encoded in the PQ curve from 0 to 519 all the bitcode values that correspond to the SDR standard. Over the 100 nits of diffuse white is where the PQ encodes all the highlight information that normally in SDR gets clipped or lost. This space is reserved for light bulbs, specular lights, fire, and all the highlight information that can go up to 10,000 nits. Currently, we don't have a 10,000 nit display. The amount of detail in the highlights that a screen can show will depend on the brightness level of the screen. The Perceptual Quantizer doesn't allow any scaling of the signal at the screen level. This means that if you're working with a 1000 nit display like the Sony BVM X300, this will make use of 75% of the curve. If you're working with a 4000 nit display like the Dolby Pulsar, it will make use of 90% of the curve. Only a potential 10,000 nit display will make full use of the PQ signal. The reason behind this approach from Dolby is to provide content creators the right tools to accurately display their creative intent, not only in the creative process where they're working with calibrated monitors, but also in the mastering and delivering instances, and keep viewing consistency throughout, which is a long-awaited goal by film professionals and media in general. There are two mastering options based on the Perceptual Quantizer algorithm. One is the one developed by Dolby, Dolby Vision, and the other one is HDR10, supported by the Ultra HD Alliance. Dolby Vision demands a 12-bit master finished on a 4000 nit screen, and HDR10 demands a 10-bit master finished on a 1000 nit screen. Hope you enjoyed this episode about the Perceptual Quantizer, and I hope I'll see you on the following episodes.